Our final reaction of triacylglycerols is saponification, and saponification is how we produce soaps. So hence the name saponification. You have seen this reaction before in creating carboxylate salts last unit, but we're going to look at it as it applies to triacylglycerols because it looks just a hint different with those fats. All right, in saponification, we're going to take a fat or triacylglycerol, and we're going to heat it with a strong base. And so we're either going to use potassium hydroxide or we're going to use sodium hydroxide. And what this will produce is a glycerol molecule, so we reform our glycerol, and it also produces the salts of fatty acids. So you have seen this before when we did our base hydrolysis of carboxylic acids. The only thing that's changing is what we're starting with. So we're starting with a triacylglycerol. We're still forming that salt of a fatty acid. The only thing that's really changed here is that this chain, this carbon-hydrogen chain, is now really long. We were working with very short chain carboxylic acids that we could name. We're out of that now. We can't do that. So let's take a look at how this works. Oh, one quick note before we do though. The type of base is going to determine the type of soap that you create. So if you use sodium hydroxide, you're going to get a solid soap. If you use potassium hydroxide, you get a liquid soap. All right, let's check it out. So when you have the presence of a strong base, this is happening in water as well, remember that your strong base is going to dissociate, okay, and it is going to form sodium and hydroxide molecules. All right, so we're going to plan on breaking our ester bonds, and we are going to, from this, reform our glycerol molecule. Okay, so break your esters right there. The hydrogen from our hydroxide is going to join the glycerol, reforming your glycerol. Okay, and I know we've discussed this as being a hydroxide that separates out. Truly, you're going to reform a carboxylic acid. It then donates the proton, and that's how we get to where we're going. But for our purposes, let's just pull it apart this way. Okay, so we also are then going to add an oxygen back to our carbonyl. So what we wind up with on our carbonyl is an oxygen with a negative charge attached to your fatty acid group. We have 3 of those, gets added in each position. We have a negative charge on that oxygen that attracts the metal ion that has a positive charge, and our sodium is attracted through that ionic bond to the oxygen. And what we reform is sodium palmitate. Again, you don't have to know the name of this, but if we started with palm oil, okay, we name the metal just like we did before, and then we name it as an ester, palmitate. All right, so you wind up with glycerol, and if these are the same fatty acids, so this is a simple triacylglycerol, you can go ahead and use the 3 coefficient and just write this one time. Remember that for our purposes, we do like to show those charges, so it's okay to show that charge because we don't usually have an ionic bond. So now we have a very polar carboxylate anion end with our metal, and we still have a non-polar end. Remember that we're forming soap. And we've talked about how soap works because it has a polar end that can interact with water and a long non-polar tail that creates that inside of the micelle. Pulls in that non-polar grease and dirt into the center, and it can be washed away. All right, let's practice this. All right, so this is going to work just the same as the last one. We are going to start by looking at our triacylglycerol. I see it's a triacylglycerol. I see we have a base. This can only be one type of reaction. It's got to be saponification. It's because you're in the saponification podcast too. That helps us to know that. We are going to break our bonds, our ester bonds, between the single oxygen and the carbonyl in the ester bond. So I'm going to start by reforming my glycerol because that is just an easy place to start. So CHO, CH2O, CHO. I'm going to draw those bond lines. And CH2O. And I am going to add in my hydrogens, reforming my glycerol molecule. So that is done. All right. First thing I want to assess is how much writing do I have to do. I'd like to do the least amount of writing possible, and if these are identical fatty acids, that would be fantastic for that goal. So each of these has 32 CH2s plus a methyl. They're identical. Fantastic. This saves me some time and energy. I'm going to go ahead and just draw what we have written once that ester bond is broken. CH3, we have 32 CH2s. I'm just working backwards, guys. And there's my carbonyl. All right, so to this, we are going to add our oxygen group, which has a negative charge. And my sodium with its positive charge is going to be attracted to that oxygen. So I reform a carboxylate salt. And that is all you are going to have to be able to say. You are not going to have to name this because you have not learned how to name fatty acids. So these really long chain fatty acids, I don't ask you to memorize that. I don't feel like that's useful for you, but you should recognize it as being a glycerol because I did ask you to memorize the structure of that, and 3 carboxylate salts. All right, it's your turn, guys. Do not cheat the process. Make sure you pause me and you give this a try yourself. Notice that we're working with a different base this time, but that is really the only change. All right, give me a pause. All right, guys, you should have made a split here, here, and here. Draw that line in the sand on that ester bond. And to each of those, we're going to reform our glycerol molecule. And here is our fatty acid. Thankfully, they're all the same, so I can just use this coefficient to designate that I have 3 of these fatty acid chains. We add in the oxygen with a negative charge, and our potassium is our metal ion at this point. So again, what would we identify? We would identify that this is a carboxylate salt. It's 3 carboxylate salts according to my coefficient. All right, so what would this look like on a test? For all of these reactions, you would probably be given the first part, and I would ask you to pick the correct products as a result or to draw the correct products as a result.